assist you guys in finding the 1-point perspective of this arch. And what I've presented you is the auxiliary front view and the auxiliary top view. My auxiliary front view is going to give me all the height information, and the auxiliary top view will give me all the width and length information. To start off with, I need an SP, a stationary point, which is me. I'm going to place it here just to give myself a little bit of perspective of this shape that I'm looking at. And what I know is everything touching the picture plane needs to be projected straight down because it's already representing itself on the picture plane. And then I've obviously got points that are not on the picture plane, and I've got to try and have them represented on the picture plane as well. So I'll go ahead and I'll connect them in construction line, and I put a little indication line on my picture plane so I can see where it cuts the picture plane of the point in the back. And what I've got to realize here is that I've got a center line that's indicating that the front portion of my shape or of my object has the same shape as the back end of my object. And in my front view, I can see what that shape is. However, when I'm looking at it from the top, from there, I will see this object over here. I'm now going to take across the total height of this object, and in this case you can either do it in a box method where you literally take the templated box and project it back to a vanishing point. However, my vanishing point hasn't been found yet, and I know in 1-point perspective that's always vertically connected to my stationary point at my horizon line. VP for vanishing point. And what I'm going to do is I'm going to feed my brain with a little bit more information. So I'm going to connect my corners to that box. So that I know I've got the parameters of the shape I'm going to be drawing. Right. I also know that the back corners will complete my box if I project these down. Right. And one nice thing about 1-point perspective is we're always dealing with a horizontal line. So I know that I'm going to horizontally place this across, and I will have it meet up with that line that goes back from that point and the bottom corner. Now, this half cylindrical shape is going to fit inside of this box over here, my constructed box. However, I have no reference points on this curve as a square or rectangle would have. So I'm going to go ahead and split and give myself some reference points along this curve at 30-degree intervals. And I can go ahead and label them 1, 2, 3, 4, 5, 6, and 7. And remember, since this is the same object as this one, I should be able to find each one of these points on this object as well. To do that, I have to open up my compass to the width. Remember, that length over there is the same as this length over here. So I'm going to open it up to half of it, and I'm going to scribe an arc. What I'm essentially doing is I'm taking this object and I'm laying it flat. I'll go ahead and I'll go split it as well into 30-degree segments. And what I do now is, since they are represented on the arc over here, 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 and so on, I can go label them from left and to the right. Number 1, 2, 3, 4, 5, 6, and 7. And already I can see that 1 and 7 are already on the picture plane or on that surface. And I'm going to project my number 2 back, but I'm going to project it all the way back, because 2 is represented on the picture plane here and also in the back. I'm going to do that with every one of my points. So 4 is in the front here, already on the center. And that's going to help me project all those points where they need to be. Now remember, they are touching the picture plane on the front surface. So I'm going to project them all the way down first. Since they are represented on the picture plane, I'm going to make little dots here for the video's sake, just so you are aware of where they are represented. What I've essentially done by representing them on the straight line is I've taken this flat object and I've picked it back up again so that it's a straight line. So I'm going to go ahead and project this 5 back down to my drawing. Okay, and because I have those reference points on my front view now as well, 2 and 6 will line up at the same height. 3 and 5 will line up at the same height. And 4 is already found. So 4 and 4 in the front will be over here. 3 and 5, 3 being on the left, simply just join them. And 5 2 and 2 and 6 and 6 and then 1 touching the ground line and 7 on the other end. Right, now that I've got reference points, it makes it a whole lot easier, because now I can just simply go and join each one of these reference points to my vanishing point. Each one of these reference points need to move towards, or are connected to the vanishing point rather, because the back end of this object needs to appear smaller. That's what one-point perspective or perspective drawing is all about. Right, now that I've connected all those reference points by simply projecting the heights of every one of the numbers and the lengths or the widths of every one of the numbers down where they meet up with one another, I've got those points now. They're all connected to the vanishing point. Now I'm going to go ahead and I'm going to try and find the ones in the back. So I've got 7 over here and 1 on this end over here. So let's go and connect them to the stationary point. In this case, I'm going to line them up with a stationary point, but I'm not going to connect them all the way down. So I'm just, for my sake, you've seen every one of these done already. So I'm going to just thicken the line on the picture plane as an indication that they are represented. So remember, every point that does not touch the picture plane must be represented on the picture plane for it to be projected down vertically. Okay, if you want to, you can go ahead and work out one by one, or you could take that number over there, which is number 7, you can label it number 7. There's number 6 now on the back end, number 5, number 4, number 3, 2, and obviously number 1. And I'm going to go ahead and project them all down. So 7 is already projected down because we found it with a box. However, 7 has got a bottom corner. So we've got to find that bottom corner rather. So I'm projected a little bit further down because 7 is going to meet up with 7. Now I'll go to 6 and I'll project 6 down. If I follow 6 and the projected one down, and 5, and I project that one down, you could label them as well. There it's going. If you have a way of identifying the front to the back, go for it, go use it. Use your own methods. Okay, 4, following that line back to 4. I use a number system, and you can see how I darken the lines at the picture plane. For my own sake, there it goes. 3 projected down. 2 connected to the back, and then obviously 1 and 1 is already connected. Alright, so now you can see all the points that need to be connected to one another. However, this is a smooth surface, it's a curve, so I can't just go ahead and connect all the dots 2 and 2 and 3 and 3. The bottom ends I can, so I'm going to go ahead and do that. However, this end over here won't be seen because there's a curve in the way. Alright, so now I can go and work on this curve over here. I'm very fortunate knowing that this curve is obviously touching the picture plane, so I know that this should line up. Okay. And due to accuracy, so I can go ahead and just test that theory. It should go through all one of those points. Yes, it does. Okay, and I go ahead and I go draw the front end of it, which is practically the template of that which is needed. Okay, and I can't simply go do the same in the back because I'm not going to have the same shape. Reason being, this is obviously the full shape or the size, and the further back it goes, closer to the vanishing point, the smaller it appears. This is where I go ahead and I go use my French curve. Now you have different kind of French curves. But you also got to remember that you're going to have some form of tangent line that's going to end here, and it looks like it is 5 and 5 at this point in time. Okay, so we're going to make sure that we get that to end at the back end of 5. There it goes. Okay, I can't see beyond that. You can see 6, which is in the back surface. It'll be in the back surface. Along that back surface, we don't see that back surface from this angle. Remember, I'm standing over here and I'm looking at this object, and that which I see is what I'm drawing over here. Okay, so I'll go ahead, take my French curve and try and see if I can find the necessary curve that will work for me. At this point in time, it looks like this will do. So I'm going to go ahead and remember, try and get this to continue on an arc on the French curve. It'll give you a little bit of an indication whether this is going to work or not. Okay, you see if I had to continue, it'll go along that line. I'm not quite happy with that connection, but the principle remains. All right, so find the correct curve here. You'll see that that curve here runs along a little bit along here. I'm connecting up some of these dots here, so I'm happy with that. And as long as it goes in, right, I think you get the point. Try and get that as flush as possible, and try and work on your line work. However, that's what you need to be able to connect the front to the back surface. And please remember that you're using this method in dividing the same way you are using it in your front view. Remember, in this case over here, you've got a flat surface that is upright, and you're laying it down so you can see exactly what that shape is, and then you're providing reference points along that curve because there aren't any real reference points. You're projecting it up to that surface, okay? That means you are lifting it back up again, and when you find those points, obviously they'll be in the back as well, you'll be able to project them down and connect them to the vanishing point. All right, guys, I hope you enjoy this video and find it very helpful. You'll find these shapes all along various drawings, perhaps in arches of buildings, within houses, window structures, perhaps some roofs, but you use the same principle wherever you go and whichever drawing that you are going to be drawing, and I hope this will assist you in that process.